Welcome to recording 1A on absolute value functions for Unit 7, Chapter 7 of Mathematics 2200. We'll be graphing the absolute value of a linear or quadratic function using both the table of values method and by using reflections across the x-axis. We'll start with the graph of this linear function y equals 2x plus 4 and its absolute value. If I put these values in for x in this linear function, these are the values I get for my y values. And if I plot those points, I get this nice linear pattern, which gives me the graph of y equals 2x plus 4. Now, let's graph y equals the absolute value of 2x plus 4. For this table, I'll be doing exactly the same calculations as over here. The only difference is I've got absolute value symbols around everything, which means that anything that was negative now becomes positive. So the absolute value of negative 6 is positive 6. Negative 4 becomes positive 4. Negative 2 becomes positive 2. 0 stays as 0. It's its own absolute value. 2 stays as 2, 4, and 6. Absolute value of a positive number is still positive. So plotting those points gives me this nice V-shaped graph. Anything that was already positive stays as positive. Anything that was 0 stays as 0. Anything that was negative, though, now becomes positive. So we get the y equals absolute value of 2x plus 4 is a nice V-shaped graph. Part of it overlaps the positive portion of the original graph. The negative portion reflects. So we reflect that across the x-axis. Like so. The yellow portion gets reflected. Now, that suggests a shortcut method for sketching the absolute value graph in the first place. We'll use the graph of y equals 2x plus 4 as a guide. We only need a couple of points to actually graph it. So we'll go with the y-intercept, where we substitute x is equal to 0. So that gives us y equals 4, so we have a y-intercept of 0, 4. For the x-intercept, we substitute y equals 0. So we've got 0 equals 2x plus 4. Negative 4 equals 2x. Divide by 2, we get negative 2 equals x. So we have an x-intercept at negative 2, 0, which I'll plot right here. So those 2 points are enough to give me the sketch of that graph. I know any part that's already positive stays positive, so my absolute value graph will overlap that. So I have overlap where the y values are already positive, and we reflect where the y values were negative. In other words, where y is less than 0. To be reasonably accurate, I have a 0.2 spaces below here, so I've got a 0.2 spaces above, and then 4 spaces below goes to 4 spaces above, etc. And the x-intercept remains the same because the y value is 0 and the absolute value of 0 is 0. So we've got our graph, that nice V shape. Next we look at a quadratic function, y equals x squared plus 4x minus 5, and the absolute value of that graph. I'll start my table with the vertex. So negative b over 2a here works out to be negative 2, so then I'll go from there negative 1, 0, and 1. And I'll substitute those values for x. Okay, so I've filled in some values here, starting with my vertex. I did add an extra row here. So I plot those points and get one side of my parabola. Now I'll use its symmetry to get the other side. So here I have the graph of my parabola for that table of values. Let's work on the table for the other, for the absolute value of that graph. So for the other graph, the absolute value graph, the calculations are the same except that we've got absolute value symbols involved here, like so, which once again means that anything that was negative becomes positive. Anything that was 0 stays as 0. Anything that was positive stays positive. So we look at just the right half of this parabola here. this part here was negative. That now became positive. And we have overlap on the part that was already positive. So I have on the left half of the parabola, this negative part has reflected up, and we have overlap where the y values were positive there as well. So we have reflect where y is less than 0. Once again, that suggests a shortcut. Let's do something similar to what we did with the linear function. We find the y-intercept of our graph, so we put in 0 for the x. To get 0, -5 for the graph of y equals x squared plus 4x minus 5. I've already plotted it. Now we put in 0 for the y, which makes this a quadratic equation we can solve by factoring. X plus 5, x minus 1 are the factors. So we have x equals -5, x equals 1. So we have x-intercepts at -5, 0, and 1, 0. Now we do need the vertex for some accuracy. And as we saw in the previous slide, the vertex works out to be -2, -9. And with a little bit of symmetry on the parabola, we have another point 2 spaces to the left here. I just dash in or dot in my guiding graph. Highlight any negative parts that are going to be reflected. So this part gets reflected, and -2, 9 becomes -2, +9, and 0, -5 becomes 0, 5, etc. And then I have my reflected portion. So there's my reflected portion, and now I just overlap the parts that were already positive. Like so. In conclusion, the graph of a linear or quadratic function can be sketched using a table of values or by using reflections in the x-axis. Reflect only the portions with negative y values, and x-intercepts of a graph cannot move during reflection in the x-axis because their y coordinates are 0 and the absolute value of 0 is 0.